Hello students, this is Zilasli Physics. Today we shall be doing current electricity, Kirchhoff's law. First, Kirchhoff's current law. Get an idea of junction. The roads are meeting one another like this. They form a junction. So you consider some wires instead of road. It's connected. This is a junction here. All the wires meeting at a point. This point is called junction. Now we are considering a junction. I1 current is entering the junction. I2 current is similarly entering the junction. I3 current is going away from the junction. Note the direction. I4 current coming towards the junction. Note this direction also. Let I5 be the current going away from the junction. So this is the complete figure with the direction of the current in the junction. So go for the sign convention. Incoming current is considered to be positive, outgoing as negative. So the statement of the Kirchhoff's first law, or KCL. Is symbolically represented. I1 plus I4 plus I2 is equal to I3 plus I5. Another statement for Kirchhoff's current law, KCL. Summation of I is equal to 0 at the junction. Now, Kirchhoff's law of junction is in accordance with the law of conservation of charge, current, energy, and both A and B. Your answer is both A and B, that is D. The junction where all the roads are meeting, particular point. At the junction, incoming traffic is equal to outgoing traffic. Now let us replace roads by wires. Second question, Kirchhoff's law of junctions is also called the law of charge, momentum, energy, angular momentum. And the correct answer is charge. Now voltage law, Kirchhoff's voltage law, KVL. Now what we have to understand, what is an electrical network? It's a combination of various electric circuit elements and sources of EMF connected in simple or complicated manner. Now Kirchhoff's voltage law states that the algebraic sum of potential differences of all components and the sources of EMF is equal to 0. The algebraic sum of potential differences of all components and sources of EMF is equal to 0. Summation of IR plus summation of E is equal to 0. Now, to understand this, we have to follow the sign convention. So very carefully look at the statements. It's mentioned over here. It shows the signs convention for KVL. That enters the register, mark it as positive, and current leaving the register, mark it as negative. It is according to the direction of the current. Or say minus sign when you traverse from positive terminal to negative terminal, and take positive sign when you travel in the reverse way, minus terminal, negative terminal to positive terminal. And this is the diagram for it. Apply Kirchhoff's voltage law KVL in a closed loop when number of loops is equal to number of unknown variables. Number of loops is equal to number of unknown variables in a closed loop. Now consider an electric network is having two EMF sources E1 and E2 and 5 resistors R1, R2, R3, R4 and R5. They are shown here. Now due to source E1, current starts flowing in a left direction. Let this current be I1. This is marked in red. Due to source E2, current starts flowing to the left direction. Let this current be I2. So this is I2. This is I1 and this is I2. We have marked it by red, and please note the direction. At junction D, both these currents meet and move to right. This current is I1 plus I2. I1 plus I2 flows through R3 from junction D to C. At junction C, current I1 and I2 again splits into I1 and I2. C, at C, I1 returns to E1, I2 returns to E2. The split at C. This is the diagram. Now consider the resistor R2. Current I1 enters in it from upward and so mark it as positive. I repeat, consider resistor R2, current I1 enters in it from upward and so mark it as positive, and current leaves it from downward and we mark it as negative. So this is positive, this is negative. Now consider resistor R4, this resistor. Current I2 enters in it from the downward direction and so we mark it as positive. So this is positive over here. Yes, entry point is positive and it should be negative. And current leaves it from upward and so we mark it as negative. So this is negative. Consider resistor R3, this one. Current I1 plus I2 enters in it from left side, hence we mark it as positive. And current leaves it from right side, hence we mark it as negative. So this is the positive sign. And this is the negative sign where current leaves R3. Consider resistor R1, this resistor on top. Current I1 enters it from the right side, hence we mark it as positive. And current leaves it from left side, hence we mark it as negative. The entry point is taken as positive and the leaving point, the departing point is taken as negative, is negative. Consider resistor R5, this one, resistor at the bottom. Current I2 enters in it from right side, hence we mark it as positive. So this is positive. And current leaves it from the left side, and so we mark it as negative. So this is negative. you don't understand it, please pause it and try to see it properly following the sign convention. I think that would make you clear. In diagram, how many variables do you see? Two, I1 and I2. We consider two loops where we apply KVL. Consider the first loop, A, D, C, B, A. So this loop, A, D, C, B, A. When we apply KVL to it. So in loop A, D, C, B, A, following the sign convention, I1, R2 should be negative. I1 plus I2 into sum of I1 and I2 multiplied by R3, so it is also negative. Then I1 R1 is also negative. Now this should be plus E1 is equal to 0. So plus I1 R2 plus I1 R3. We are opening the bracket. Plus I2 R3 plus I1 R1, and we have changed the signs. Minus E1 is equal to 0. Now this is the complete diagram. We again pause it, please, and look at this very carefully. Now we consider the second loop, DCEFD. DCEFD. And we apply KVL to it. I1 plus I2 into R3, negative of that. I2 R5, negative of that. Plus E2. I2 plus I2 R4, negative of that. Following the previous direction is equal to 0. Now we open the bracket. So it comes minus I1 R3 minus I2 R3 minus I2 R5 minus I2 R4 plus E2 is equal to 0. Now this much for today. Following this, you can do numericals on it. Numericals are set on this. And this is the sign convention I used. You can also use a different sign convention following other books or notes. But remember, whatever sign convention you are following, you should complete the whole numerical with that sign convention only. Don't mix up with the sign convention of mine and other different sign conventions. So a particular sum will contain a particular way of or particular sign convention. So thank you from Zilastri Physics. Please don't forget to subscribe the channel, like it, write comment on it, and also share it. Thank you.